On January 15th, a plane descends toward Prudhoe Bay, Alaska. It's 2 p.m. The sun set 2 months ago and won't rise for another 3 weeks. Outside temperature, minus 40 Celsius. Wind chill, pushes past minus 60. Workers step onto an ice runway in total darkness, pull on 30 pounds of survival gear, and begin a 21-day shift, drilling for oil in conditions where exposed skin freezes in under 30 seconds. 3 weeks on, 3 weeks off, repeated for months. The crews live in modular camps floating on pilings above permafrost. They operate machinery that can't be turned off because thermal contraction cracks engine blocks. They eat from kitchens that never close and sleep in soundproofed rooms while half the camp works the opposite shift. They watch for polar bears on infrared cameras and wait for medical evacuation planes that can't fly in blizzards. How do you build a habitat that can't touch the ground? What does the human body require when cold doubles caloric burn? Why does irritability spike at exactly day 14? And what happens when the only supply road exists for 3 months a year, then melts? The flight from Anchorage takes 2 hours. Workers board in daylight and land in darkness. The Boeing 737 touches down on a runway made of compacted ice, lit by portable flood towers. When the cabin door opens, the temperature differential is 70 degrees Celsius. Breath turns to ice crystals instantly. Eyelashes freeze together if you blink too slowly. Inside the terminal building, workers collect duffel bags and move to the gear up area. The base layer is merino wool or synthetic fabric. Cotton is forbidden because sweat-soaked cotton pulls heat from the body and causes hypothermia. The mid-layer is fleece or down insulation. The outer shell is flame-resistant coveralls and parka, rated to minus 50, required because of explosion risk around wellheads. Boots are military-issue vapor barrier bunny boots with rubber shells and wool liners. Total weight of the full outfit, 25 to 30 pounds. Before exiting the building, workers perform buddy checks. They inspect each other's faces for gaps between goggles and balaclavas, check that gloves overlap jacket cuffs, and verify that neck gaiters cover exposed throat skin. A 2-centimeter gap between a glove and sleeve can cause frostbite in minutes. The walk from the terminal to the crew bus is 40 meters. The cold has texture. It presses against your face like a physical object. Inhaling through your nose causes pain. Workers breathe through balaclavas to warm the air before it reaches their lungs. Breathing unfiltered air at these temperatures can cause bronchospasm. The bus has been idling for hours. Shutting it off means it won't restart. The heater runs at maximum. Windows frost over from the inside within minutes of passengers boarding. Workers strip off outer layers immediately because the interior temperature is 25 degrees Celsius. Overheating in full gear would soak the base layer with sweat, creating hypothermia risk the moment they step back outside. The ride to camp takes 20 minutes along a gravel road marked by reflector stakes every 10 meters. Visibility is near zero. Headlights illuminate swirling snow but reveal no horizon. The landscape is flat tundra, no trees, no hills, no reference points. Drivers rely on GPS and stake markers because in flat, light conditions, depth perception collapses. Workers commonly trip over small drifts or equipment because their eyes can't judge distance. The camp appears as a cluster of yellow lights suspended in blackness. Prefabricated modules form the camp in a grid arrangement. Each module is a steel-framed insulated box measuring 12 by 60 feet, trucked in during the previous winter when the ground was frozen solid. In summer, the tundra becomes impassable muskeg, waterlogged soil that can't support vehicles. No building touches the ground. Every structure sits on steel pilings driven 8 meters into the permafrost. The pilings are hollow tubes containing thermosiphons, passive heat pipes filled with refrigerant. When the ground tries to warm from the building's heat, the thermosiphons draw that heat up and radiate it into the air, keeping the permafrost frozen year-round. Buildings sitting directly on the ground would melt the permafrost. The soil would turn to liquid mud. The building would sink and collapse. The gap between the building floor and the ground is 1 meter. This airspace prevents heat transfer and allows maintenance access to the underside of buildings. Arctic foxes and occasionally caribou shelter in these gaps during winter. Dormitories, operations center, and mess hall connect via utilidors, enclosed heated corridors wide enough to walk 2 abreast. Workers move from sleeping quarters to the dining hall to the gym without stepping outside. The utilidors house the camp's lifelines, insulated water pipes, sewage lines, electrical conduits, fiber optic cables, and steam pipes. All must stay above freezing continuously. The camp's power comes from 3 diesel generators running in parallel. Total electrical consumption is roughly 800 kilowatts, enough for a neighborhood of 200 homes. The generators run continuously. Stopping them requires a controlled 6-hour shutdown process. Restarting in extreme cold takes another 4 hours, assuming nothing froze during shutdown. In practice, the generators only stop for scheduled maintenance once every 3 months, and only one shuts down at a time. If one generator fails, the other 2 carry the load. If 2 fail, the camp operates on minimal power, lights, heat, and the kitchen only. If all 3 fail, battery backup provides 90 minutes to execute emergency evacuation. After 4 hours without power, the water pipes freeze. Once pipes freeze, they burst. The camp becomes uninhabitable until thaw and repair is completed, which can take weeks. Water is trucked in from a treatment plant 7 kilometers away. The plant melts snow and ice, filters it, and stores it in heated tanks. Insulated tanker trucks make 3 deliveries per day. Toilets use vacuum flush systems like aircraft, consuming less than half a liter per flush instead of 6. This reduces sewage volume, which matters because sewage can't be pumped into the ground. It's stored in heated tanks and trucked out weekly. If tank heaters fail, sewage freezes solid. A Semir crew then uses high-pressure hot water lances to melt and chip out the frozen waste, the worst assignment on site. The human body generates heat through metabolism. In temperate climates, the basal metabolic rate for an average adult is roughly 1,800 calories per day. In the Arctic, that number doubles. The body burns fuel constantly to maintain core temperature. Physical labor adds to this. A worker on a 12-hour shift can burn well over 4,000 calories. Oil companies have learned that underfed workers become hypothermic, make mistakes, and quit. The solution is unlimited food, available around the clock. The camp kitchen operates in overlapping shifts because half the crew is awake at any given moment. There is no fixed breakfast or dinner time. Workers eat when their shift schedule dictates. The menu is designed for morale. Dinners rotate through steak, king crab legs, prime rib, salmon, and lobster. Fresh vegetables fly in weekly from Anchorage via cargo plane. Fruit bowls are restocked daily. The kitchen keeps multiple types of bread, potatoes, and always, and a salad bar. Desserts include cheesecake, pies, and cookies baked on site. This abundance serves a strategic purpose. Food is the primary currency of morale in an environment with no sunlight, no scenery, no privacy, and no escape. Steak night, typically Wednesday or Saturday, becomes a temporal landmark in a week that otherwise has no distinguishing features. Workers discuss what was served, rate the quality, and anticipate upcoming meals. The dining hall is the social center of the camp. It's where hierarchies relax slightly, where workers from different shifts overlap, and where routine is broken by variation in the menu. The cost of this food is extraordinary. A gallon of milk costs the company 18 landed. Fresh produce arrives by air freight at 5 times its retail price in Anchorage. Logistics teams calculate the landed cost of every item, which includes purchase price plus fuel, labor, and overhead to deliver it to camp. Workers eat differently here. Portion sizes are enormous. Second helpings are routine. The cold is relentless in its demand for fuel. Standard carbon steel becomes brittle below -40 degrees C. At -50, it shatters under impact, like glass. Arctic drilling rigs use low-temperature alloy steel that has been impact tested at -60 to ensure it absorbs energy without fracturing. Rubber loses elasticity in extreme cold. O-rings, gaskets, and hydraulic hoses become rigid and crack under pressure. Arctic equipment uses synthetic compounds that remain flexible to -55. Tires develop flat spots overnight where they rest on the ground. The rubber temporarily loses shape and becomes squared. Drivers must drive slowly for the first 20 minutes to generate friction heat, which softens the rubber and rounds out the tires. Diesel fuel creates wax crystals at low temperatures. These crystals clog fuel filters and starve engines. Arctic diesel is blended with additives that prevent wax formation down to -50. Even with additives, fuel must be kept warm. Fuel tanks have insulation and heating elements. Fuel lines are wrapped with heat trace cables. Motor oil turns to gel below -30. Arctic machinery uses synthetic oil rated to -60. Even this oil thickens significantly in extreme cold. Cold starting an engine at -45 requires an engine block heater, an electrical heating element that keeps the metal and oil above freezing. The result is a philosophy of perpetual operation. Front-end loaders run continuously, moving snow and equipment. The drilling rig operates for weeks, pausing only for scheduled maintenance planned months in advance. The most used tool on an Arctic rig is the steam lance. Steam lines run throughout the facility, supplying high-pressure hot steam to handheld nozzles. Workers use steam to melt ice off valve wheels, railings, blowout preventers, stairways, and equipment housings. Ice accumulates constantly. Drilling mud splashes onto metal surfaces and freezes instantly. Condensation from exhaust vents creates icicles. Every surface exposed to air becomes coated in frost. Steam lances run continuously during every shift. Workers wear flame-resistant insulated coveralls, heavy gloves, and face protection. Assembling this gear before each shift takes 10 minutes. Removing it indoors is immediate because overheating is a risk. The transition between outside cold and inside heat is jarring. Workers step into the airlock, peel off outer layers, and feel their skin prickle as blood flow returns to extremities. Fingers ache, toes throb, faces flush red. The first week on site is marked by novelty and adrenaline. Workers are alert, social, and motivated. They adjust to the routine, learn the layout, and settle into the rhythm of 12-hour shifts. Sleep is difficult the first few nights because of constant generator and ventilation hum, but by day 5, most workers adapt. The second week is harder. By day 8 or 9, novelty is gone. The routine feels mechanical. Conversations become repetitive. Workers begin counting days until departure. Companies have learned to watch for day 14, the point at which camp fever sets in. Camp fever is colloquial shorthand for a cluster of psychological symptoms: irritability, difficulty concentrating, lethargy, shortened temper, and a pervasive sense of being trapped. Workers describe it as the 1,000-yard stare, or going flat. They stop making eye contact. They eat alone. They skip social activities they participated in during week 1. Multiple factors converge. The 65-day polar night eliminates natural circadian rhythm cues. Workers live in artificial light with no variation in color temperature, brightness, or duration, unless deliberately engineered. Vitamin D deficiency develops quickly without sunlight. Serotonin production drops. Physical isolation amplifies the strain. Workers share living space with the same people for 21 consecutive days. They work together, eat together, and sleep in adjacent rooms. Small irritants become magnified. A coworker who chews loudly, another who taps a pen during meals, someone who talks too much, someone else who never talks. These habits are ignored in normal work environments where people go home at day's end. In a closed camp, they become sources of rage. Companies have developed countermeasures. Vitamin D supplements are freely available in the mess hall and encouraged by camp medics. Sleeping quarters are soundproofed with acoustic panels and heavy doors. Quiet hours are enforced between 10 p.m. and 6 a.m. for each shift, prohibiting loud conversations, music, and recreational activity in common areas during designated times. The camp gym rivals many commercial fitness centers: treadmills, ellipticals, free weights, a squat rack, and a bench press station. Exercise is the most effective psychological release valve. Workers spend an hour or more in the gym daily. Lifting weights and running on treadmills provide a sense of control and measurable progress in an environment where work is repetitive and days are indistinguishable. Internet access has transformed Arctic camps in the past decade. Starlink satellite internet provides high-speed connectivity that allows workers to video call their families, watch streaming television, and maintain a connection to the outside world. 10 years ago, camps had limited email access and no video. Workers reported feeling cut off from life. The mental strain was significantly worse. Current workers can FaceTime their children at bedtime, see the news, and feel tethered to home. The digital lag, video freezing for a second, audio dropping, serves as a reminder of distance. But the connection itself is psychologically critical. Routine becomes a survival strategy. Workers create strict personal schedules: wake, shower, gym, breakfast, work, lunch, work, dinner, call home, read, sleep. The predictability provides a sense of control. Breaking routine is destabilizing. By day 18, workers enter the countdown phase. The end is near enough to feel real. Energy increases slightly. Conversations return. Tempers ease. Polar bears are apex predators with no natural fear of humans. An adult male weighs 600 kilograms and can run 40 kilometers per hour. In the perpetual darkness of the polar night, a white bear is effectively invisible to the human eye. Camps are attractive to bears. Kitchen exhaust vents release food smells. Trash is stored in heated enclosures. Bears investigate both. Camps employ designated bear monitors, security personnel who patrol the perimeter and monitor infrared cameras. The cameras detect heat signatures. A bear's body temperature is warmer than the surrounding air, making it visible as a bright shape on a thermal display. When a bear is sighted within 500 meters of the camp, Code Black is called over the radio. All outdoor work stops immediately. Workers retreat to the nearest building. Entry airlocks are sealed. Security personnel grab hazing equipment, cracker shells, beanbag rounds, and air horns. The goal is to scare the bear away without harming it. Killing a polar bear is a legal and public relations disaster. Polar bears are protected under the Marine Mammal Protection Act in the United States and international treaties. Lethal force is permitted only in immediate defense of human life. If a bear charges a worker and security shoots it, the company faces federal investigation, potential fines, and intense media scrutiny. Environmental groups protest. Future permitting becomes more difficult. Hazing works most of the time. Cracker shells, pyrotechnic rounds that explode in the air with a loud bang, startle bears and drive them away. Beanbag rounds fired at the ground near the bear create noise and dust clouds that encourage retreat. Security personnel escalate hazing gradually, using the minimum force necessary. Most encounters end with the bear leaving after a few cracker shells. The problem is habituation. Bears that are hazed repeatedly learn that the loud noises don't actually harm them. They become tolerant of cracker shells. Over time, some bears ignore hazing entirely and must be physically relocated by wildlife authorities using tranquilizers and helicopters. Relocation is expensive and logistically complex. Medical trauma presents a different kind of danger. Every camp has a dedicated medic, a paramedic or nurse with trauma training. The medic runs a small clinic equipped to stabilize heart attacks, broken bones, lacerations, and burns. Serious injuries require evacuation to a hospital in Anchorage or Fairbanks, which means a flight of 1 to 2 hours. The weather determines whether evacuation is possible. Medevac helicopters and fixed-wing aircraft cannot fly in blizzards, whiteouts, or high winds. If a worker suffers a severe injury during a storm, the medic must keep that person alive with limited resources until weather clears. This can take hours or days. The psychological pressure on the camp medic is immense. They work alone. They have no backup. If a patient deteriorates despite treatment, the medics must decide whether to continue aggressive intervention or shift to comfort care. They carry the moral weight of outcomes they cannot control. The golden hour in the critical first 60 minutes after traumatic injury, when treatment is most effective, is a concept built around urban emergency systems, where hospitals are minutes away. In the Arctic, the golden hour is often unattainable. The medic does what they can and waits for the weather. The North Slope of Alaska is accessible by road for approximately 90 days per year. From January to early April, the tundra is frozen solid. The rest of the year, it's impassable. Summer tundra is a waterlogged sponge of moss, mud, and shallow ponds that cannot support vehicle weight. Even tracked equipment sinks. During the frozen season, specialized crews build ice roads. The process begins with a survey team using ground-penetrating radar to measure ice thickness on rivers, lakes, and tundra. Once the ground is confirmed frozen to at least 60 centimeters, construction begins. Crews use water trucks to spray thin layers of water over the snow. The water freezes into solid ice. Layer after layer is added until the road reaches 15 to 30 centimeters thick. The road must support the heaviest loads, drilling modules, generators, and prefabricated camp sections that can weigh 50 tons or more. Ice quality matters. Blue ice is solid water with no air bubbles. It's strong and reliable. White ice contains air pockets and is structurally weaker. Road builders constantly test ice quality using core samples and radar. Weak sections are reinforced with additional layers. Convoys move slowly. Speed limits on ice roads are typically 25 miles per hour. Driving faster creates a pressure wave. When a heavy vehicle crosses a frozen lake, it pushes the ice down slightly, creating a wave that travels through the water beneath. If the vehicle drives faster than the wave propagates, the wave can bounce back and amplify, causing the ice to crack under the truck. Drivers maintain steady, slow speeds and space vehicles far apart to avoid cumulative wave effects. The ice road season is a logistical sprint. All supplies, equipment, and materials needed for the coming year must be trucked in during this 90-day window. Fuel, food, spare parts, drilling pipe, cement, chemicals, everything. Companies plan convoys months in advance, coordinating shipments from suppliers in Fairbanks, Anchorage, and the lower 48 states. Missing the window has severe consequences. If a critical component fails and the replacement part wasn't stockpiled before the road melted, the operation must shut down until the next winter. A single missed delivery can idle a rig and its crew for 8 months, costing tens of millions of dollars. Climate change is compressing the window. The tundra freezes later in autumn and thaws earlier in spring. Ice roads that were reliably usable for 120 days 2 decades ago now average 80 days. Companies adapt by increasing convoy frequency during the available window and building larger on-site warehouses to stockpile a year's worth of supplies in a shorter time frame. On day 21, workers pack their duffel bags and board the bus to the airstrip. The plane lifts off from darkness and climbs through cloud cover. 30 minutes into the flight, the first faint glow of twilight appears on the horizon. By the time the plane descends into Anchorage, it's midday and the sun is visible. The transition is abrupt. Workers step off the plane into noise, car engines, voices, construction equipment. The smell of trees and vehicle exhaust is overwhelming after weeks of odorless cold and recycled camp air. The visual complexity, buildings of different heights, moving traffic, people in varied clothing, feels chaotic after the uniform white tundra and modular camp. Some workers report disorientation. Colors seem oversaturated. Temperatures in the positive teens feel warm. The weight of normal clothing feels insufficient. Walking without 30 pounds of gear feels unnaturally light. Sleep patterns remain disrupted for several days as the body recalibrates to natural daylight. The 3-week break passes quickly. Workers spend time with families, catch up on deferred maintenance at home, and rest. Some use the time to travel. Others simply sleep and recover. By day 18 of the break, the cycle begins again. Workers receive their flight itinerary. They pack their duffel bags. They board the plane in Anchorage and fly north into the dark. The oil is still there. The demand for it remains. The infrastructure exists to extract it. Workers return because the pay is high. The work is steady, and the rotation schedule allows for extended time off. They return because they've adapted to the rhythm. They return because this is the job. The Arctic doesn't change. The cold remains. The darkness returns every winter. The ice roads freeze and melt on schedule. The modular camps hum with power and heat, suspended on pilings above permafrost, keeping workers alive in an environment that would kill them in minutes if the systems failed. The workers rotate in and out, 21 days at a time, extracting oil from beneath frozen ground in a place where the sun disappears for 65 days, and the only warmth is what humans engineer.